Hello everyone, this is Sai Sri and welcome back to my channel. So in this video, let us see some coordinate systems. These coordinate systems are very useful in analyzing the transmission signals in EMTL. So firstly, in this video, we see the Cartesian coordinate system, and in the another video, let us see the cylindrical. So firstly, we have to know what is meant by a coordinate system. So the definition is, it is defined as the system which is used to represent a point in the space. For example, this is a plane. There is a point here. So in order to know the characteristics or the electric field around this P, we have to do some analysis. So we can do with the coordinate system. So we have many types of coordinate systems. One of them is the Cartesian coordinate system. It is also called as rectangular coordinate system. So the definition here, it is telling that it is defined as a system which is used to represent a point in the space. So it tells about the characteristics or the field around the system. So in this way, the coordinate systems are very useful in EMTL. And here it is also known as rectangular coordinate system. And here we have AZ. So here A suffix Z bar, A suffix Y bar and A suffix X bar. These three are unit vectors. Unit vectors are nothing but they are having the magnitude 1 and normal to the given plane or the system. So those are called as unit vectors. So next one is the differential elements in coordinate system. For example, let us differential means there is a change. What is meant by differentiation? There is a certain change. We represent as d by dx. So there is a small change or the big change. So the change is represented as the differential. Here we take the point P. Here we are having the three axes. One is x, y, z. So x is here, y and the z. So these are the three axes. And there is a point P having these three coordinates x, y, z. So here we are considering a point P which is having x, y and z. And differential means there is a change. So as there is a change, we are changing the x, y and the z. And the changes are represented as the dx, dy and the dz in the respective axes. So let us increase the coordinate by a differential amount. A new point P bar will be obtained having the coordinates P dash x plus dx, y plus dy, z plus dz. So here the coordinates, so here it is the original point P. We have changed the point to here, and the distance between these 2 points is the dl, that is the change in the length dl. So as the point position is changed, the axis positions also changes. So the new point here we got is P dash, and the change in axis is the dx. So in the x-axis the change is dx, the small change is the dx, and the change in the y-axis is the dy, and the change in the z-axis is the dz. So these are the three changes caused due to the change in the position of the point P. So that is what we have written here, the dx. The differential change is also known as elementary change. It is nothing but a small change. Dx is the differential length in the x direction, differential length in the y direction, and the differential length in the z direction. So here we got how these axes are changed with a small change. Now let us know what is the magnitude, what is the volume, and what is the direction of these axes after changing from point P to P. In the coordinate system we have x, y, z. So here it is a small change in length. So the P position is changed from P to P dash, and the change in length is dl. So here we represented this as x, y, z with having the unit vectors. What the unit vectors tells is the direction. The direction of the x-axis is told by the unit vector ax bar or ax cap. It is the unit vector symbol. And the y is represented as ay bar. It is ay cap. This is az cap. So these tell the direction. In the same way, here also the points ax cap, ay cap and az cap will tell the direction. So in the same way, dl bar is the change in the length. So in order to tell the direction of this length, we take it as dl bar. Dl bar is nothing but differential vector length. The change in the length, we are taking it in the direction, so it is called differential vector length. This is also known as elementary vector length. So it is nothing but dx, dx, dy, dz. These three represents the magnitude, and ax bar, ay bar, az bar represents the direction of the dx, dy, dz respectively. So these are the unit vectors. Here it is the original point. This is the vector joining the original point P and a new point P bar. So this is the change in the length, right? So the vector representing the change in length is the dl bar. And in order to know the magnitude of these, we have to just square these points, dx square, dy square and the dz square. So the magnitude of the differential vector length is dl. Mod dl bar is dx square plus square root of dx square plus dy square plus dz. If you want to know the volume of this differential change, the small change, the formula is going to be dv is equal to dx, dy and the dz. Previously we represented the element wise differential change, how the change is happen in element wise, like x-axis, y-axis and the z-axis. Now let us see how the change will takes place in surface area. Surface is nothing but either we can have xy, yz or zx. Any two axes we are going to have in surface. But if you take the volume, we will have the all the three axes. Now coming to the differential surface area, it is represented as ds bar, same like as we have represented the change in length as dl bar. That is only change in one direction or the change in only one element. Here there is a change in two elements, that is represented as ds bar, which is nothing but the differential surface element change. And the formula is ds an bar. It represents the magnitude and it represents the what direction. Here an bar is nothing but the unit normal vector perpendicular to the plane. The unit vector is nothing but, for example, if you take a surface like this, the unit normal vector will be in this direction. So upward, the direction will be in the upward, that is unit normal vector. So where ds is the differential surface area of the element and an is a unit normal vector to the surface ds. So let us see some of the surfaces. So how they will change. Here we are taking the three surfaces. Here the unit normal vector will be the ax. Here it is, for example, if you take, so if you take this axis, the x-axis, here we can see it is an x-axis. So this will be the unit vector. If it is the unit vector, so the changes will be dy and the dz. This will become as the unit vector. So the formula of the ds, the surface of this picture is, this surface is ds suffix x bar is equal to the remaining two surfaces and the unit vector ax bar, a suffix x bar or the x cap. This is the unit vector. So this is for this surface. So when this surface is for example, this is x surface, this is another one, this one, then the unit vector will be in this direction. So this is the second one. So here ay will be the unit vector and the dx dz are the other differential change in vectors. So ds bar y is equal to dx dz and the ay bar. And the next one is in the z direction, so upward. So the paper, if you take this as a surface, it will go in this direction. So then the unit vector will be az bar and the two differential vectors is the dy and the dx. So this is the formulas for the others. So here dx is the differential vector surface area normal to the x direction. ds y bar is the differential vector surface area normal to the y direction, and the other one is the z direction. So these are the formulas for the differential surface elements in the Cartesian system. Here the formula ds x bar is nothing but when we are considering ds x bar, then we have to take the differential change of the other two. That means here if you see dsx, then we are taking dy and the dz and the unit vector ax bar, and for the dsy bar we are taking the other two differential changes. What are the other two differential changes other than y? They are dx and the dz, and we have to take the unit vector of that surface differential change, that is ay bar, and the other one similarly we have to take the third one also. ds z bar is the differential change in the other two coordinates, that is x and y, and into the unit vector az bar. So in the next video, let us see the cylindrical coordinate system and the differential surface elements, volume changes and etc. So this is for the Cartesian system. Here we have x, y, z. If you understand this concept, then you can apply or you can understand the cylindrical coordinate system better if you understand this. So the next part 2 or the next lecture on the cylindrical coordinate system, I will drop the link in the description box. Thanks for watching.